Hi, my name is Jan Wilczek from WolfSound.com. Welcome to WolfTalk, a podcast about audio programming. In this podcast, you will learn how to build your career in programming or research related to audio, meet programmers and researchers from all around the world, and learn about the intricacies of sound. Hi everyone, and welcome to the 21st episode of the WolfTalk podcast. And today I have a very special guest for you, namely Fabian Renn-Giles. So some people say that you don't have to introduce him, but I will do so nevertheless for people who come to this podcast from outside of the audio programming space. So Fabian is a former lead developer of the Juice C++ framework, which is currently the largest C++ framework for doing audio plugins and audio applications. He's a real-time audio C++ expert who worked with the greats like iZotope, but not only this. And this title of an expert or a guru is, I would say, really well-deserved in the sense that basically everyone agrees that he's one of the go-to people when it comes to real-time audio programming. But that's not all he's done throughout his career. He's been at the Audio Developer Conference from its inception. Actually, he may be one of the people who actually started the conference, but he also he has given talks not only at the Audio Developer Conference, but also at CppCon, which is the largest C++ conference in the world. And he also gave a few other talks, which are all available online. And I highly suggest you checking those out if you're interested in real-time audio programming. I think Fabian and also Dave Rowland are most famous for their talk, which was called Real-Time 101 from Audio Developer Conference 2018 or 19. And in that talk, they introduced all the caveats of real-time audio C++ programming. And this talk gets cited over and over again. People reference it all the time. And that's why it's really amazing to have Fabian on the podcast, because we also be discussing this. But we'll also discuss how to learn audio and real-time programming. We'll discuss, can C++ be still used for greenfield projects today? We'll also discuss the story of Juice and the story of the Audio Developer Conference and much, much more. I'm super, super excited about you listening to this episode. If you'd like to check out the people, places, and references mentioned in this podcast episode, I highly encourage you to check out the episode notes at thewolfsound.com/talk021. Once again, it's thewolfsound.com/talk021. And if you like the podcast, if you like to support it somehow, then please subscribe to the YouTube channel, leave a thumbs up on YouTube, and consider leaving a 5-star review on Apple Podcasts or Spotify. And if you have a suggestion who you would like to be the next guest on the podcast, then please do so in the comments on YouTube or in the episode notes. And finally, if I may say so, if you want to become someone like Fabian, or at least set out on this journey and start learning about audio programming, then I have a resource just for you. It's my free audio plugin developer checklist that you can get under thewolfsound.com/checklist. It lists every bit and piece of knowledge that I believe is necessary to become an audio developer. So head over to thewolfsound.com/checklist. And now, Fabian Renn-Giles. Hi Fabian, thanks for agreeing on the interview. Could you please introduce yourself to the audience?
Yes, thank you. I'm Fabian Renn-Giles. I'm a C++ audio plugin developer, audio app developer, and I've been doing that for a long time now. And I'm really looking forward to talking to you.
Yeah, likewise. So could you maybe share where are you from? Because I know that you traveled a lot, and then when did your interest in music start? How did that look?
Right. Okay. Well, I did travel a lot. I was born in Germany, but when I was 2, I moved to the US. I lived there until I was 11. Then I was a year in Luxembourg. I was a year in Switzerland. My parents came around. Eventually moved back to Germany when I was, I think, like sort of 12-ish. I must have been around that time. And my father was in a rock band, like hobby, and he loved, technology. So he had a Yamaha DX7. He had a Chroma, one of these very old keyboards. And I inherited all his gear sort of when I was 8. So I had it under my bunk bed. I had like a nice console and all of this stuff, and then a very old Mac 2SI. I don't know, for the people my age, they'll be happy to hear these shout outs to this old gear. And so I was doing, MIDI music from a very early age.
Awesome. And so you were playing the keyboards, or did you have any professional training?
Right. No, I mean, I did learn how to play piano, but I was never a very decent piano player.
I understand. And then from what I learned from your official bio, so to say, in 2004, you started studying physics at the Heidelberg University. So was it motivated by music, by the interest in music somehow?
That's a good question. I mean, I was always strong at one point I dabbled. I was thinking I might want to be a composer. I really loved composing things, with my MIDI set. Like I had I composed a few soundtracks for some very, very early computer games that were never successful. But I did dabble in that, but I also loved maths. I really loved maths, and then I loved computers as well. So maybe as a short anecdote, if I may, my father was one of the first people to have a computer at home, and he had an old IBM PC, the original IBM PC, and my brother and I started learning programming on that PC when I was like 6, right? And there was a children's programming language called Logowriter. It's still there today, but basically back then you could move a turtle and have it draw some things. And my brother, mainly my brother, I was a bit too young still. He programmed the whole like jump and run side scroller with that. And my father saw that and thought, well, that seems strange. I don't think you should be able to do this with this programming language. And he sent it to the company LSI in Canada, who makes Logowriter. And they then sent back a professional C++ compiler suite. MetroWorks Code Warrior, very expensive at that time. Back then compilers weren't free, were very expensive. And so this company so kindly, saw that there's some kids who are doing some crazy stuff, sent us a really expensive package of C++ compilers. And that's when I really started getting into coding. So I've been coding C++. I can really say since I've been 8, I've been dabbling in C++. That's a long answer to your question. But so when I had to choose what to study, it was something between music, maths, but also computers. But computers almost seemed too obvious for me. I was already back then in school, I was already working for big companies like Behringer to do their drivers. So I did that while I was in 10th grade and financed some holidays with that money. And it seemed almost too the easy route. You have to imagine back then in the late 90s, the web was just taking off. There was this incredible shortage of developers. So I was being asked everywhere to please help. And a very nice person at Behringer actually at the time said, don't do that, right? You'll regret it. Like do something that's really hard, that really challenges you. And so that's why I studied physics. So that was a long answer to your question, but I think it gives you a bit of background where I was at that time.
Yeah, definitely. And it kind of reminds me, if you want your child to be a master violin player, they need to start very young. So I guess that you did the same thing with C++. Just start early.
Right. Yeah. I started very, very, very early. And, I was just incredibly lucky for some of these companies that were out there that really helped me along the way. And I think this will be a recurring theme of this interview. I had so many mentors in my life that I'm so grateful to, even at a very early age.
Okay, awesome. And that kind of explains why when you started studying, again, at least in your official bio, you also founded Fielding DSP.
Right.
And so was it like, the let's say professional wrapper around your activities at that time?
No, it was so funny. I have a friend, his name is Johannes Auer, and he's back then, I think more, now a bit less. He's a sort of a semi-famous music producer in Germany. And he was also studying physics. And I remember I was in the studio once and he was like saying, I wish there was a plugin that does exactly what Reviver does now. And I said, well, sure, I can program that. And 2 days later, I'm like, here, I really coded it like in an evening. And he was like, dude, you can sell something like this. And I'm like, nah. And it's like, no, we should really, like, just for fun, let's try selling it. I'm like, nah, let's not do that. And he's like, no, come on, let's try it. And then we were laughing. I mean, I think, we had so much fun with what name should we give this company? And it was basically a joke. We were like, let's give this name. It should sound like a company that's been there forever. That's like this old British institution. So as a joke, we gave it the name Fielding DSP. And it's so important to know, like, getting something to work for a friend, you can do in an evening. Making something work with like an installer, copy protection, all the testing on multiple platforms, that took at least, another month or two. But it was fun, and we had no plans on this succeeding, really no plans. And we sent it to some magazines at the time. The online world was just catching up. And we hit the publish button, and we were just in awe that people started buying it instantly. And it was an instant success. And that is just crazy to us. We never thought that this, I have to say, back in the time, this was very early 2000s, 2004, I think. There just weren't that many plugins on the market. So it was a different time. But yeah, that's how Fielding DSP came. And it's, I'm just reusing this company for all my endeavors now. And it's kind of funny that the name stuck, really.
Yeah, I got it. That like the idea was to have like Fielding International or something similar. Yeah. And I'm just curious, like, which digital audio workstations run your plugin, and what format was the plugin back then?
Originally, it was AU only. So we had a first version that was audio units, and this was done with Johannes Auer, and then we had another sort of finance guy as it sort of took off, Christoph Kaup. So that was us three in the beginning, and then Johannes Auer was less involved, so he moved out of the company, and then when I moved to the UK, I met Tom Poole, who is very famous now, also running ADC, and he joined Fielding DSP, and he helped me write the VST version for Windows, and he actually wrote an AX version, which we never actually published. But that's kind of funny; it's a small world. So he was. And then at one point, I bought out the other founders outright and just kept Fielding DSP to myself. Yeah.
Okay, awesome. But how were you able to?
Oh, sorry, which DAW? That was.
Oh yeah, sorry.
It was Logic. It was just audio units, so it was just basically Logic on Mac, and then later it was basically all of them.
Okay. And what I wanted to ask then, how were you able to combine the work there with your studies? So after this initial plugin, did you also release other plugins?
No.
Okay.
No. I think, doing a PhD gives you some time to do other things on the side. So I think that was it was definitely doable. I mean, it was just a single plugin, so it's not a big deal. Yeah.
Okay, thanks. So exactly, you mentioned the PhD. So as I understand, after graduating from the Heidelberg University, you went to do a PhD at the Imperial College. So was this also part of this do something difficult approach?
Yeah, I think so. I mean, yes. I mean, again, after my studies, I was like, should I do full-time computing? It's strange, and I don't know really. There, there was always, I mean, up until a certain point in my life, I was always pushing myself to learn more. Like I never wanted to do the easy route. And it was only during my PhD that I really realized, I was already 30 then, and I was already 32, and I realized I'd always had the feeling like, oh, I still just have to finish this, and then my life starts. I always had this feeling like I just have to finish my, in school, you just have to finish your school, and then your life starts. And then you're studying. It's like, I just have to make it to the diploma, and then my master's, and during my PhD, I just realized, wait, this is my life. This is, and that's when I noticed, no, I don't always have to give myself such a big challenge. I think it was good for my early years, but I had to have this realization because I wasn't doing something that was really fun for me. I was just pushing myself and constantly pushing myself. Where at one point I knew during my PhD, like, no, I actually want to do things that I really enjoy, and that was computing and music. And I don't know where I got that strange inclination that I always pushed myself to do hard things that I wouldn't go so far I didn't enjoy, but they were very hard, right? It was a lot of work. So yeah.
I think it's it may be kind of a personality thing, and that you always have this drive not to follow the easy path.
Right.
But I think that the audio community is grateful that you took the hard route.
Well, I mean, for me, going to the audio space was the easy route, and it's been easy ever since. And because it's so huge, my passion. So in some ways it was misguided because, a big life lesson I learned was, my PhD, I think, it would have been, I regret doing my PhD. And I can honestly say that. Some people say, oh, a PhD wasn't worth it, but I still learned a lot of life lessons. And for me, no, I didn't learn any life lessons. Like it would have been better. I would have followed my passion earlier. I think my physics studies were great. There you learn how to learn, and, math is always good for computer science, but why I just didn't follow my passion sooner and had this strange push to do things hard. I don't know. It was a mistake. It was 4 years of my life that I could have spent doing better things.
Okay, that's very honest thing to share, I think. But could you maybe briefly say what was your PhD about? What was the topic?
It was quantum optics.
Okay. Sounds pretty complicated. I can spoil that the next question is going to be about the JUICE C++ framework, where Fabian has been the lead developer. But before we continue, I'd like to explain what JUICE is for those podcast listeners who are not familiar with it. JUICE is an open-source, cross-platform C++ application development framework that makes it easy to create audio software, as well as audio plugins and plugin hosts. You can write code once and build VST, AU, AUV3, AAX, and LV2 plugins on Windows, macOS, iOS, Android, and Linux, as well as embedded platforms. I've been successfully using JUICE since 2018, both in my private and professional projects, so I'm delighted that they're sponsoring the podcast. I especially like how JUICE makes it easy for beginners to jump right into creating audio plugins and applications without worrying about C++ quirks. JUICE is used by the majority of the world's most important audio companies, but it is free for personal use, and there is affordable pricing available for companies just starting out. Apart from the framework itself, Juice has an amazing community of users gathered in the Juice forum, which is a great resource to learn audio programming on its own. To start using Juice now, go to juice.com, juce.com, download Juice, and follow their Getting Started guide. I have also put the link to it in the description. Have fun creating audio apps and plugins. And now, back to the interview. Okay, so after completing the PhD, then you immediately went to work for Rolly on the Juice C++ framework, where you eventually became the lead developer. And could we maybe take this occasion, because I don't think that's widely known. Could you maybe share the story of the Juice C++ framework?
Mm-hmm. Well, I mean, Jules is the godfather of Juice, right? It's in the name. It's Jules, utility, classes, and I think the E just added. And he wrote that, I think must have been 10 years before I even joined Rolly. And it, it was interesting because when I ported my plugin to all of these platforms, I wrote sort of a Juice competitor, and I wanted to market that. I wanted to sell that. And then I think Tom Poole sort of made me aware that Rolly was looking for a developer to join the Juice team. And at that time, I was a complete solo developer. I learned all of my computing skills myself, with mentors, sure, but no formal education. And I didn't have anybody to check in, right? I didn't have anybody to. So when I finished my PhD, I remember telling a friend, I don't know if I'm a really, really bad coder or if I'm a really, really good coder. I really didn't know it, right? And it's also because developing audio plugins is a very different space to some of the traditional coding things. So if you look at books, they have, they say, if you don't follow MVP patterns, then you're a bad programmer. And it's very, very hard to do when you're writing an audio plugin. You can't follow these patterns. So, some of my physics colleagues said, you're a complete failure the way you write code. You're not following the MVP pattern or whatnot. And so I really didn't know where I was. So I knew I needed to join a company before I try something out myself. And what better? I was writing a Juice competitor than not actually join Juice. And so I interviewed there, and I started as a junior developer there. And it was the best single moment of luck in my life, I have to say. I would be somewhere completely different if I hadn't had that opportunity at exactly that moment. I was sort of the first employee on the Juice team. Jules had managed this 10 years on by himself, and then Juice got bought by Rolly, and then Rolly had funds to add another developer to the Juice team, and that was me. And imagine having, Jules, this rock star developer, absolute genius, and I'm one-on-one with him, next to him at his desk. And I could not imagine a better mentor than Jules. I mean, Jules was an amazing, amazing mentor. I mean, he did see my potential. It turned out, I actually was a pretty good developer, but you'd also notice that I was developing on my own for a long time. And so he noticed my potential, but also taught me in a way that was never condescending, taught me in a way, always, if I felt strongly about something, he let me go down that rabbit hole and fail. I think what's so important in a mentor is letting people fail. And he did. And, on the Juice team, failure was very public. Right? It's open source. And there's the forum. And defended me in my decisions. And I mean, I could, the years that I worked with Jules were that was so great. And it was a huge launch pad, right? Because Juice is used by so many. All of a sudden, my name was associated there. I became known. So, I mean, an immense stroke of luck there. Yeah.
Okay, awesome. And I can also imagine that, apart from if you are a good or a bad developer, it's also entirely different thing if you develop a piece of software on your own and you developed it in a group, right? So could you maybe share what were the challenges of developing the framework at the time you joined the project from the programming perspective?
I think what people don't realize often with Juice is that at times I would say 80% of Juice work was forum work. So you're 20% you're developing new features, and 80% people on the forum say this doesn't work or that doesn't work, or here we have a bug, or we're using it in this use case and it's not quite right. And that's very challenging because it's hard to plan things, right? I think Juice is a really unique product as it being a product for developers, and it has a very close relationship to the developers via the forums, but it's also used in immensely different fields, right? So critics of Juice would say Juice is so bug prone, it's full of bugs, and partly that's right. I think Juice has changed its philosophy a bit, but I think the other reason is you have this framework that is very extensive. It has cryptography, it has audio, MIDI, it has graphics, it has all of these, 3D graphics, it has all of these components to it. And then people use it in games. We've seen people using it in finance. We've seen people using it in telephony applications. And those were big names, right? And so it's so hard to predict what people will use your software for. And so, how should you test that, right? I mean, it's something very different if you're writing an app where you know what the people will be doing with the app. But here you're writing a framework and people are combining all of these modules in different ways and using it in completely different settings on embedded Linux systems, on Linux desktops, on phones. I mean, that's a completely different game. So every morning we would open the forum and then see the amount of things that don't work. And then we would try to fix them. And that's a challenge because you never really have a plan. You can never really say what I'm going to do tomorrow. I mean, that's also a feature, but it can also, I think eventually that's why I left Rolly, is it does start to become very tedious. It's a lot of work. It's really, really a lot of hard work. And you make mistakes and you're criticized openly on the forum. So, to bring it back a bit more back to your question, is you have to write every line of code in a way that it will be scrutinized by hundreds and hundreds of people, and that makes it hard to write certain types of codes because it doesn't give you often time to sort of test things, right? To write like, okay, let me write like a first really simple crude implementation and then see if that works. And if it doesn't work, I go back and then change it. And so, yeah, so that makes it very, very hard, but it's also a really good teacher to how to write good code, right? Because, the people on the forum could be really, really ruthless, right? They were like, they would find your dumb mistakes that you wrote at 10 p.m. at night, they would find all of them. So you really double check your code again and again and again, and then they still find stuff, right? So that was definitely a challenge. Yes.
Yeah, that's. I have never thought about this kind of community aspect to this kind of open source framework. That's completely right. What I always consider the biggest challenge in such projects is that as soon as you make one thing public, it essentially needs to remain public, or you need to launch this complicated procedure of deprecating stuff. And so I don't know if you can answer this in any way, but what was kind of the process of deciding on the, let's say, interface of a class or like public functions, etc.?
That's a really good question. I think if it was a new feature, it was always just discussed with the team, and I mean the person responsible for it would suggest something, and then the team would criticize it. And at Rolly we did have the luxury that we had another company, like the whole Rolly company, using the Juice product. So if it was really a new interface, a new API, and not just fixing things or adding, a lot of Juice features are just adding support for a new Mac OS version or adding support for this. Like there's no API change, it's more backend work. But if it really was a new API, we would first dog food this to the other Rolly teams, and they would give their feedback. So I think just more feedback, the more feedback, the merrier. But we did do huge API mistakes that we really regretted. And I think it's still, you can still see that in Juice today.
Okay. So is there anything you'd like to share on this, or we should skip this?
Oh, no. I was responsible for this whole multi-bus thing, right? And man, that was just, it was, so in Juice, people always love to point that out, that was a complete car crash in the beginning, and that went like multiple public iterations and it's still not right. If I would be able to write it again, I would still write it again. But the whole multi-bus API for like long-term juicers, they all know what that was because it was a complete car crash.
Okay.
So, but I don't know. There are many examples.
Okay. So people can look through the forum,
right?
But in any case, I can imagine that apart from just consulting each other, you also needed to try to get like an inspiration or information on how to develop such a versatile framework from other sources. So were there any resources that you personally use, or were there any other frameworks that you could reference at that time?
It's hard for me to answer. I would have to, almost pass that on to Jules, because Jules was just the guiding light there. Even when I was lead developer, I would run all big decisions just by Jules, as he was still my mentor at the time. And for Juice, there's a saying that Jules always said, and I still say that so often to people I mentor now, or when I'm in a team. And Jules learned Java first, and then he learned C++. And he always told me, Fabian, how would you write this in Java? Write it that way. And now I have to really back off what he means with this, because if you just take it like that, but this is one of the best single pieces of advice that Jules gave me, is there are a lot of C++ developers who tend to over-engineer. And especially if you're very mathsy, if you're very theoretical, you like writing things with templates, and you want maybe, I don't know, everything to be stateless, and you go overboard with templates and with maybe polymorphism and template metaprogramming, and then you write that and you notice you're going overboard, and then it's sort of hard to find what is the middle ground. And Jules saying, think of like you're writing Java is not saying, he was basically telling me I wasn't a very good Java developer. So if I would write something in Java, it would be plain and simple, right? It would be class, methods, and that's what he was telling me. It's like, write your APIs like you would write Java, or I don't know what it would be for you. Maybe for you it would be write it like you would write Python. You wouldn't write any fancy stuff because you wouldn't know how. And I still have that in my head every time today. It's like, I still often go overboard, and I think I need to template everything, and then it's just no, wait, how would I write this interface in Java? Like how would it look like there? And I think if you look at Juice today, you really see that inspiration. It's if you look at the headers of Juice, it almost gives you the Java feel. It really does. And so maybe if inspiration for frameworks, quite surprisingly, maybe it is Java. Yeah.
Okay, that's very interesting, but it may be the answer to the fact that Juice framework is the code of the Juice framework is very readable. So even if you are not very experienced and you come inside, the rabbit hole, you understand what is happening at every level.
Exactly. And this is something that I know Jules always did with my code, and we always did together. And some of the best advice, and if you take it out of context, it sounds stupid, but believe me, like this advice is so important. He would zoom out the editor until you cannot read the code anymore. And you would get this bird's eye view. And he does this in one of his talks at ADC, actually, one of his keynotes talks. And you can really see by just the syntax highlight and the colors if you wrote good code or not. And, and it's this sort of bird's eye view, like doesn't look too dense. And by writing comments and splitting things out into functions, your code actually really does get a different look. And I think this is also what's more inviting, right? If the code is very dense, people go like this. And so really that zoom out trick is really, really interesting. And some of this advice goes against some of the popular advice out there. One other piece of advice that Jules gives, and I'm such a huge proponent of, is don't use out of formatters. So you can use out of formatters as a first pass, but it's actually so important. For Jules, it was so important how the code looks like, right? And that's, you can say all you want about this opinion, but Juice is successful. And exactly as you say, people look at the code and it's inviting. And one of the things he said is, for example, often you have boilerplate code that's like copy paste, and you can get rid of it with templates, right? But then you have templates and nobody knows what you're doing. So rather copy paste that boilerplate code, but make it clear that it's copy and pasted, but with formatting, right? Like often you have like a table, right? Like with, every company and a URL and then parameters, make it that almost looks like an HTML table, right? Like make the brackets all align. And if you auto format things, that will just go away. And so sure, like use auto format as a first pass, but then go over it again and do things like this, like with the formatting, make it clear that this is a copy and paste, make it clear that this is a really simple for loop, so you're not even going to put a bracket around it. I think that's really, really important advice to make code invitable and maintainable.
Okay, so thank you, because that again explains some parts of the Juice framework to me, exactly as you said, that it looks very hand formatted, so to say, something that an auto formatter would never produce.
Right, yeah. And it's totally against, current opinion, right?
Yeah. So we talked a lot about Juice, but then eventually you decided to leave the project, as I understand, based on the reasons you already mentioned. So could you maybe describe how did you go about switching from working for Juice to being then a freelance developer?
Sure. I knew I was. There were two things. It was getting tedious doing the forum work, but Jules did offer me to then work on Soul, and I just knew. When I got that offer to work on Soul, I wasn't happy. But I knew that I couldn't really progress anymore. So there was this point where I also wanted to. I also didn't want to work under Jules anymore, and not because he's a bad person, but I want to almost like graduate now. I've been under Jules so long, and I want to graduate and do something on my own. And when I sort of recognized this feeling, not everybody gets an offer to work on Soul, and that didn't make me happy, this offer, and I really had to introspect, like, why doesn't it make me happy? And I realized, no, I kind of want to graduate now. I want to be on there on my own. And that's when I started to slowly ramp down Rolly and move up contracting.
Okay, awesome. So in the contracting space, you've worked with the greats, so to say, of the industry, like iZotope. And could you maybe share how these contracting jobs come about? Because I can imagine not every developer out there is asked to work with iZotope.
Sure. I again, that luck that I had joining the Juice team, an immense amount of luck, because I was just very well known in the space then. And at the same time, also at Juice, what happened was the founding of ADC. And so, I was there from the very, very early days. And I give anybody the advice who wants to do contracting is to give talks. I mean, that was that along with Juice, of course, that turbocharged. After every talk I give, people come to me and say, wow, that was such a good talk. Can we have you for this project? Right. Every talk. So ADC is my must go to event to get new customers. And I think I've got all my customers through ADC. So it's super important to give talks if you want to be in this space.
Okay, awesome. And that already ties in to my next question. So maybe is there any other advice that you would that you could give to people who would like to become freelance audio developers like you? Like, obviously you need to work on the Juice team first, but
right.
But other than this,
give talks for sure. I think there's more work out there than you think, and so getting in touch with other freelancers is really important, because I think many other freelancers have to pass down work a lot. So having a network, I think, is great. There's this unfair thing in all of work life, I think, though, is that some of these jobs that I get offered, I can't say, I'm not going to say which jobs. They're very easy jobs that even a more junior person could do. But these big companies gave me the job because they need absolute 100% certainty that the job will be done in a timely and good fashion. And, there's no silver bullet for that. That's just, you have to have a certain amount of work on your CV that you have proven, and, where you sort of go up the ladder slowly. There's just no skipping that, I'm afraid. So it's really important to have a network and to understand that needs to happen. On the other hand, I would really say, and this could be risky advice, I don't like it when really successful people give advice, just follow your passion, everything will be great, because they've had a lot of luck. I've had a ton of luck. So take this piece of advice that's about to come with a grain of salt. But for me, it definitely worked to not be too hard on myself and to follow my passion. So for some reason, and maybe I'm just super, super lucky, if I had some technology that I was passionate about, that I found myself doing on the side instead of doing my actual work. One point in time, I get super interested in synchronizing clocks, like this geeky idea, maybe for my physics thing. And I almost started neglecting my real work. And then and it was always the right choice to just say, no, I'll just do this for a few months, and it always paid back 5 times, Then I got this job at Sing to do exactly that, synchronize audio between, different Wi-Fi speakers. And it was so much fun. I had a blast doing that job because it was exactly my passion. And then you do a really good job, and then it's word of mouth. So I think when I speak to junior developers, they're like, yeah, I have to do this, and I don't really feel like it. And my code is such a mess. But I'm writing this game on the side. I'm writing this audio engine on the side. And really, take the risk and just do that audio engine full time, and don't feel bad about doing that. Don't beat yourself up and say, I'm procrastinating. I don't know. It's then again, I also have the fortune that my parents aren't poor. They're not super wealthy, but they're not poor. And so I also always had this, I knew that if everything goes wrong, I could always ask my parents, like, I never did it, but I could, technically I could have gone to my parents and said, oh, I need to pay the next month's rent, and they would have helped me out. And so I'm a bit uncertain giving this advice, right? Because, if you come from a different background, maybe it's not the right advice, right? Maybe that could put you into ruins. I don't know, right? So, but that's certainly how I experienced it.
Yeah, that's such an important point, that what you mentioned about the family background, and I think it also is always an important factor, even when you study, for example, right? Because if you're studying and you don't have to do some work that's completely, uninteresting, but you need to work to earn for your rent, for your studies, etc., then you kind of waste this part of time on something that you could do related to your studies, to your interests, etc.
Absolutely. Yes, I cannot put it better. It also gives you this, I think, this self-confidence, right? Like I just say, oh, I'm going to look at my interest.
Yeah.
And if you were raised with money isn't the problem, I mean, it's not really, I don't want to say my parents are rich, but like it wasn't as a kid, I never felt like money was a problem.
Yeah.
And that gives you a completely different, self-confidence in taking risks.
Okay. And maybe last question, because we diverge a little bit from the topic of the grades in the industry, but I was curious to ask, were there any learnings that you got from working with such big companies in particular?
Oh, yes. Oh, for sure. If you work with these big companies, right, they are ruthless in their recruiting. They only take the very, very best. And so I'm under average at best, right? The people there are just crazy intelligent. And so, that is such a huge amount of luck to be working with some of these people. It's really great.
Okay, thank you. Thank you for sharing this. How are you able then to find the balance between, your private life, your professional life? Are you coding all day, this kind of thing?
Oh, not at all. Not at all. I mean, when I was younger, yes, I was coding a lot, but that was by choice. Like, it was never because I had to, I just wanted to. But now, I have different priorities in life. I have a small child, and I can only recommend anybody who has a work-life balance problem to have children, because you won't, it's the best thing. I pick my daughter up from kindergarten, and then if you're not completely there with your child, I don't know if you have a small child, but
no, not yet.
But your child will notice, right? Like, you have to be present in the moment, and you have to be on the floor with your child, and I don't know, and so I have a very strict, right now I hardly ever work more than 6 hours really concentrated on a project. And as a contractor for some projects, I need to, charge hourly, and there, with having eating lunch and all of these things you do, I very rarely do I work more than 6 hours. And it doesn't mean that I'm often in front of the computer 8 hours, but then there's like admin, there's emails, and then like real work is very, very seldom over 6 hours. And then weekends, I never work unless there's a deadline. Sure, there's always like the deadline, and then I do like crazy, 12 hours for a few days. That definitely always happens. But if I'm not in deadline mode, then I don't work on the weekends. And I don't know, if I wouldn't have a child, I'd probably be working on the weekend. So I wouldn't take that advice too literally. Like, if you have children, it's just, you have different priorities, and you don't really want to work that much. So, yeah.
Yeah, I think it's a very, very beautiful approach, I think. All right. So I would like to now transition more to the technical topics. And the first question is, I think everyone listening to this podcast is dying to ask. So you're known in the audio programming community as this real-time audio master / guru. Of course, not self-proclaimed. And the question is, how did you learn real-time programming, and how can others learn it?
That's, you're an educator, and so yeah, this might be really valuable or interesting for you particularly. There are sort of two schools of thoughts on how to teach programming, right? You have sort of this high level approach. You start with a game, you teach sort of, this is a shared pointer, blah, blah, blah. And you don't really explain what the pointer is and how memory works. And so that's sort of the high level approach. And then, the more advanced you get, the more you then explain, a pointer is actually a memory address and memory works like this. And I don't think that's certainly not how I learned it, right? I did the bottom up approach. So, and that's really because when I learned programming, computers were so simple, you just needed to know how memory works, right? There was no multitasking. There was no memory separation. It was all just, and you needed to write, so yeah, old computers, you need to really work very close to the hardware. And I think that gives you a really good, unique perspective on how real-time systems need to work, because you really understand the memory system and you understand the hardware. And that's, I think, my approach to real-time programming. That's maybe how I learned it. But I learned it late. The first time I heard about real-time programming was from Timur Dumler, and another, also working at Rowley. Rowley was this crazy place. Tom Poole working at Rowley. All of these people came out of Rowley, and what a great place to be at. And I was coding some stuff, and he was saying, Fabian, that's not real-time safe. And I was like, no, of course it is. And he was like telling me, really, no, like this is a data race. And he was introducing me to undefined behavior. The first time I heard undefined behavior was from Timur. And so and maybe I got so much into it because at first this was something I really didn't understand. And I was been programming with C++ for so long, and there was this like new part of C++, which really, like, at first I didn't even believe Timur. I was like, you can't be right. And so I really threw myself into this and really wanted to understand it very, very deeply. So I guess so these two things, that's how I learned this.
Okay, so this kind of ties into my feeling that I think audio programmers would benefit from reading books that focus on operating systems and their APS and architecture.
Totally. Absolutely. And I think, also back to what I said earlier, I think there's a lot of junior developers who beat themselves up because they're like, I'm not following MVP. So if you read general C++ programming books, it's, even like test-driven development, like even the most hardcore test-driven development proponents like Timur, very, very strong test-driven development proponent, he will say it's not always easy to apply to audio. And there are certain exceptions you have to do with audio, especially the way sort of the UI is linked up to audio. You can have so many bugs there, right? Because you have this real-timeness of you moving a slider and that changes the audio. How do you write a unit test for that, right? It's like you would have to somehow simulate the mouse. Like, it's very, very hard. And especially at that interface, though, there's many, many bugs. You have the message thread changing the slider, and then that goes somehow to the audio thread. But that whole part you can't really test with test-driven development, because you would need something sort of controlling the slider. It's very hard to do with test-driven development. And it's very hard to navigate as a junior developer, because you have these books that say, like, you need to do test-driven development. You need to do this. You need to follow MVP. And then you go into the audio space, and it's like, no, actually, test-driven development is good for some parts. Maybe like your DSP functions, it could be good, and some of your business logic. But then there's a whole bunch of other stuff where you just can't use it. So I think I got a bit off topic there.
Yeah. But I agree. But I also know that some people will take what you said and say, oh, like in audio, you cannot do tests at all. And they'll just neglect tests.
Exactly. So it's so important. I mean, like and another Jules quote, Jules in his guideline says should never write new, you should never write delete. This is like his rules. And then I was writing some code and I was like, oh, it's so hard. It would be so easy if I just write new here. And then his advice is, break the rules. You can always break the rules if you have a reason to break the rules. And it's such a simple thing, but it's just, your default should be to adhere to the rules, write test-driven development. And then if you're noticing I'm not doing it, then have a good reason why you're not doing it. And and a good reason is a good reason, right? That's fine. Then don't do it, right? So again, with test-driven development, your default should be test-driven development, but then you're noticing, this part I can't really test, like this part of the user interface and part of this. Well, then don't, just, have a mental reason about this. Think about it for a moment, why you can't do it. And if you have a good reason, then don't do it. And don't try to shoehorn something in. And so, maybe I think back to your question is reading operating system manuals, I think is so much better, maybe to understand how the computer works and then learn coding from that, because, a lot of the C++ literature is just not meant for audio. And I know my advice would also be is use a lot of Godbolt and look at the assembly. People ask me, do you need to learn assembly to be a good coder? And don't learn assembly so that you can write assembly, but learn assembly that you can read assembly on Godbolt. And Godbolt gives you hints, right? So, again, you don't need to memorize all of these assembler instructions, but be confident enough that you can quickly grasp what's going on from the assembly in Godbolt. Because that will give you so much knowledge of, I showed this in my real-time talk this year at ADC. I was showing assembly, like how the assembly changes, and it gives you so much more in-depth knowledge of what's really going on under the hood.
Thank you. And while we're at it, are there any resources apart from Godbolt that you would recommend for learning assembly?
The thing is, I have never opened a single programming book. I've never learned programming or all of this stuff by reading books. So no, I learned assembly by reverse engineering. I hope the statute of limitations is gone, but when I was a child, I had Digital Performer, but it wasn't a real copy. So I learned it by reverse engineering copy protection, and that was when I was like 10, and that's how I learned it. I never had a book, so I
Okay, yeah. So it makes total sense to kind of experiment with this. Yeah.
I think Godbolt is a huge resource, and I would go so far, if you're really interested in this space, for my generation, an academic career was good learning, but nowadays, I'm learning. I had, for certain contracting jobs, I had to learn Swift, and I had to learn it to a really good level. And ChatGPT and online videos and tutorials and things like you do, your platform, what a wonderful platform you have there. I think I signed up to a platform to learn Swift, and it's so much better than whatever I experienced in university. You have exercises and videos and online tools, and then ChatGPT. What a miraculous wonder to learn new stuff. I have a tab open on ChatGPT every time I'm coding and learning Swift, because I'm just bombarding ChatGPT with questions. And the great thing about ChatGPT is I can tell ChatGPT, I'm an expert C++ programmer. Please explain anything in Swift, knowing that I'm an expert C++ programmer. And I'm, also, many of the Swift explanations, again, I like to learn from the ground up. So I tell ChatGPT to explain it to me on a hardware level, like really what's going on, like what happens when you have all of these Swift concurrency stuff, which threads are happening and how is the locking happening. And ChatGPT is great. It will happily comply and even show me like assembly snippets of what it think. You could imagine like that this assembly is being executed. I mean, there's no better time to learn computing stuff, and academic qualifications are becoming more and more irrelevant. Sure, you can have it, but then you need to prove your knowledge more, right? Than having it on paper.
In this sense. Okay, so it actually counts what you know and what you can do rather than the letters after your name.
And we had this. Sorry, I'm really going on a tangent here. But we had this topic about inequality. As you said, sending somebody to university is a financial decision that has to be made. In Germany, university is free, but even then, you have your support. Your kid is not earning money, right? So, and platforms like yours, where there's no sort of infrastructure attached, where there's no requirements for all of this, what a huge benefit to society. Yeah.
Thank you. That means a lot coming from you, and I really like your advice on telling ChatGPT to explain you something like you are a C++ expert. It's kind of a higher level of this concept, because I don't know if you've seen, but there are quite a few books, like something like Java for C++ developers, or vice versa. But here you have any possible combination, right?
Right.
So that's really, really cool. And maybe one more question on ChatGPT. So how should have you found it making mistakes in some way? So are there any? Okay.
Sure. And if it doesn't know something, it kind of it doesn't outright say something wrong, but it kind of like keeps on repeating itself without really answering the question. So I have that a lot. And so in preparation of my ADC talk this year, I was asking about like memory models on RISC-V and on all of these different platforms. And RISC-V, a very new platform, you could tell it just didn't know. I was like trying to pinpoint down like if this instruction does something atomically or not. And it would always say like, well, if it did do it atomically, it would be like this. And if it doesn't, it would do it like this. And it was like, yeah, but answer the question. And it just doesn't answer the question. And then you kind of know, okay, you're reaching the limit of ChatGPT. But, with programming, it's so great because, you have instant results, basically. Your program crashes or it doesn't compile or it does. So, I'm not a lawyer where I have to sort of, or a doctor who is like, I have to rely on this being correct. It makes mistakes, it tells you some code and you paste it in, it doesn't work at all. But that's a lot more forgiving in the programming space.
Okay. But thanks for recommending this resource. And I'm also curious if ChatGPT will replace the need for my platform as well.
No, I don't think so. No. There's something about, humans. There's no, it won't. I think with ChatGPT, you really need to, it's great for learning like a new language, but, expert knowledge in that new language, you would need a human for sure.
Okay, thanks. Okay, so while we're still in this topic of real-time audio, so I could not interview you without asking about the talk. So the talk that you gave at the Audio Developer Conference 2019 with Dave Rowland, called Real-Time 101, because it seems to be like the most widely cited ADC talk of all time. So could you maybe share the story of this talk? How did the idea came about, and how did you and Dave prepare for it?
Okay. That's really funny, actually. So Dave, is an incredible speaker. He, in the olden days of ADC, there also used to be a competition of best speaker. He always won first place. And I sometimes I came in second or third, but he was always first place. And so one year, it turned out we both wanted to do the same talk. I was showing Timur like a pre-outline of my talk, and then Timur said, "Hey, Dave just sent me an outline that looked very similar for me to also look at." And so I contacted Dave, and he was like, "Hey, it'd be dumb if we do the same talk. We're both good speakers. It would be bad if we sort of somehow stepped on each other's toes, and then we decided to do it together. And that was a really good decision. Dave brought so much insight into this talk, and Dave is an incredible speaker, and he's definitely one of the best programmers I've ever met. It's not many people who have programmed their own DAW that's incredibly successful, and Dave has done that. And so that was, I think that's why the talk is so successful. So you had like the two people who have very good real-time knowledge come together and prepare this talk. So that's the story behind the talk. Yeah.
Okay, and what was the feedback that you personally received after giving the talk?
So, I'm really surprised. So I think maybe the motivation for the talk, let's just go back again. There's many books that give you, I always like books that give you programming patterns, and especially in concurrency situations. And then there's tons of concurrency patterns out there. There's books that's just called concurrent. There's like this book I have that's just called concurrency patterns. And there's sort of the worker pattern. And then there's the critical sections and whatnot, like all of these concurrency patterns. And it's always, when I'm not doing real-time programming and have something concurrency, always look at that book and find the right pattern. Because if you write it yourself, you're going to make mistakes. Like, always try to use a pattern. But there was nothing in the real-time space. So there was no like flow chart you could go through and say, this is the right pattern for this, and this is the right pattern for this. And so that was really our guiding light for this talk. But I don't know, maybe other speakers could relate to this, but my talks before then were okay-ish successful. And then we had this talk, and you go in there as a speaker, and it's almost like especially at ADC, but also we also give this talk at Meeting C++, you're amongst other experts. And so this is a suggestion, right? You're saying like, look at this is like our approach. But you're not saying like this is the approach, right? Well, that's the feeling you go into this talk. But then it became to this thing as like, this is the approach. And, that almost shocked me a bit. I had people saying like, wow, I use this as the reference. I'm like, oh my God, you're using that as the reference. Yeah. So I don't know, that really, I really didn't expect the success of that talk. I really didn't expect that.
Okay, but you're totally right in the sense that I feel again with audio, it's again this special case. For example, there was a talk by Anthony Williams at one of the latest CppCons about how to use concurrency with C++20. At the end, he says, oh yeah, and there's this thing like atomics, but you don't need to use it in most of the cases. And that was the end of the talk.
Right, exactly.
And then so I think that exactly like the talk like you gave together has become this go-to resource that you need to study to kind of maybe, not understand everything fully, but at least get a grasp of what the problems are and what the possible solutions are.
Absolutely.
Yeah. And tying into this, which is maybe a little bit more sad, because in a subsequent talk that you gave, and also what I've seen in the talks given by other respected developers, and I think it also speaks about their level of professionalism, that they're able to go out and say, hey, in this talk in the past, I did a mistake, right? I said something wrong, or maybe I wasn't clear enough. And then my question is, if such professionals like yourself and others, make mistakes in this domain, so how can we expect, an average developer to get it right, or even, like let's say junior audio developer to do it right?
You can't. I mean, that's just this. You learn by doing mistakes, I think, and I think this theme of don't beat yourself up, don't be too hard on yourself. I know something I learned from Jules. Jules allowed me to do all of these real-time mistakes. And, you learn so much from debugging as well. So don't try to get it right I'm mentoring someone right now, and some advice I gave this person was that try to use too little real-time safe constructs, to err on the side of too little real-time safe constructs, and then see how it fails and why it fails, to really learn. So what should I say about that? It's hard, right? And people make mistakes, and you'll make mistakes as well. Maybe I just like to add, maybe I wouldn't say that the real-time 101 talk, that flow chart or anything I said in there is grossly wrong. I really wouldn't say. I think it still holds up very, very much. And I think following that flow chart is still very, very good. I think there's some new patterns that I've learned about that I would add in the flow chart. But, if you just take that flow chart, I think it will suit you well. What I really noticed was, and why I wanted to do a follow-on talk, was that, this was almost like a suggestion to the community. And I felt like it was being taken too dogmatic, So people were avoiding locks at all costs. And, this is a technicality, but, in the original talk, I said, you can't use locks in real-time code. And that still holds. But people use this like anywhere where I have an audio thread, I can't use locks. And, in the talk, I know it's not published yet, but in the talk I did this year, I'm trying to say, well, really think about if your code at that point needs to be real-time safe. And maybe if you take that lock, real-time guarantees are no longer there. Because I saw people like trying, again, this shoehorning things in. And, maybe if this is the theme of this interview is don't be dogmatic about these things. Don't be dogmatic about test-driven develop. Don't be dogmatic about my real-time 101 talk. And I was trying to show with this follow-on talk, like, look at all of these exceptions and look at all of these things where locks really do make sense. And by all means, it doesn't mean you can now just use locks in real-time code. Like, no, definitely not, right? There are certain situations where it might not be that bad to use a lock, right? But don't be dogmatic about it. If you have a good reason to use a lock and you think it's okay in this context, then by all means use it, and so that's something I wish I would have had a different, maybe I could say the real-time 101 talk had the emphasis in wrong places, maybe, and needed a follow-up there.
Okay, but then again, don't be too hard on yourself.
Right, exactly. Yeah, okay.
Staying in the realm of C++ still, I think everyone agrees that, audio code should not just be real-time safe, but also performant. And I know it's a very broad topic, and I know it's outside of the scope of this interview, but is there any general advice that you could give on writing high-performance audio code? And again, if you have any resources that you could recommend on this.
I would say God bolt and being able to read a bit of assembly. That's really it, because you will immediately see if it's performant or not. Right. I mean, not for the, like, if you want the last percent, then you would have to, like, the assembly is not enough. You have to know about cache concurrency and all of that. But really the biggest mistakes in performance, always when I'm consulting, is that you look at Goldbolt and you see, oh, there's a call, whoa, that's always, always that call instruction is the one that should be like, whoa, something went wrong. Something didn't inline, something, normally DSP routines never have a call because it can almost always inline everything. And there's only ever a call when you're like doing a double floating point division on an embedded hardware, because it can't do that in hardware. So it has to go emulate that, something like that, So looking at the assembly and just looking if it's expected and seeing if it was vectorized. And that's also another thing. Did the compiler, because that's a bit of a black magic. I have this one forum post on vectorization on the Juice forum, if anybody's watching this, which is sort of my brain dump on, and it's really a bit of a dark art, right? Because the compiler sort of has to just, it's like some heuristics for the compiler to guess like what the programmer is intending, and then write some completely different assembly. That's basically what the compiler is doing to have the same outcome. And of course, the compiler doesn't always guess right? It doesn't always understand what you're trying to do. And so you'll be surprised in Goldbolt. You just change one line and all of a sudden it vectorizes. And I have some examples in my talk, that's not public yet, where you'd be really surprised when all of a sudden things change because the compiler has known, this could alias. This is one famous example is if you are doing some processing and it's not in place, like the output array is different than from the input array. Often the compiler will not optimize that, and the reason is because the input and the output arrays could overlap, and so you cannot do a vector operation, right? Because it could be basically recursive, right? If they're overlapping that just by one, then the compiler is not allowed to vectorize it, right? Because and so some of these things, and there's this great CppCon talk on this topic of looking at Goldbolt, and there's they're called Clang performance annotations. There's this talk I also mentioned in my talk, but my talk is not public yet. But it's called, the talk is on Clang performance annotations, and I would suggest everybody to watch that talk, because Clang has a mode where it will tell you why it didn't optimize a certain piece of code, and there's so many reasons why Clang is not allowed to sometimes optimize something. And that's how you learn how to write performant code, because you just again, Goldbolt is showing me Clang didn't optimize this because of this and this, and so you start to learn these by heart, and then you just write performant code in one go, hopefully.
Awesome. I think it's also a great tip always to look at assembly, because it maybe apart from benchmarking, but I guess that benchmarking has its own caveats on its own. But I feel like there's so much, preconceived notions surrounding high performance C++ code. Something like people say, you need to use pointers to be more performant, etc., etc. So I think looking at assembly, it's kind of
totally,
unveils all
absolutely,
this.
Absolutely. I think there's so much like, no, you need to write assembly to have performant code. You need to write, I don't know, I very rarely did I have to write vector instructions by hand. Very rarely. I think that there are definitely situations where you need to do it, but it's rare. And part of this forum post where it's on SIMD register, which is a juice class, which allows you to write sort of vector instructions by hand, but in a cross-platform way. I wrote SIMD. I wrote that for Juice, but in that forum post, I actually persuade people to not use it. I see so many people using it prematurely, and there's also a reason why many junior or even senior developers, they use like these things like SIMD register. There's a huge problem with that. Is that the compiler sort of, to be able to inline all your code, has to sort of be able to see through your code. So even if you're writing code that should be performant in practice because you're using SIMD register, you will suddenly hit compiler bugs. And this is not a rare case. If you're really writing a lot of DSP code and you're using like lots of templates and SIMD register, the compiler will suddenly not inline some function that is so obvious it should inline, and it just won't do it. And it's a compiler bug. You can report it and they're like, here. And there are many on that level, right? Like it's just something, and so I see often senior developers overusing templates, overusing SIMD instructions by hand, and after a while you really get a feeling for how much improvement writing SIMD instructions by hand really does. And it does often give you an improvement, but it's usually like 1%. Really, is it really worth it? Also the maintainability for like 1 or 2%?
Yeah, exactly. I'm happy that you mention it, because I've seen it time and time again that SIMD instructions written by hand reduce readability a lot. And then it's so easy to make a mistake in such a by hand written code. Good that we have all these tools then. And another area that is also a big interest of yours is are the audio APIs, so the very low-level audio APIs. And you did a great talk on the Audio Programmer Meetup about the Linux audio API, so the ALSA. And again, my question is, how did you learn this stuff? And are there any, because now is your talk, so it's a resource already, but are there any other resources than just, trying things on your own or reading while reading documentation?
I read documentation, but the documentation is horrible for ALSA, really, to be honest. But, you look at other people's code. I think that's what I did there. Their Linux is great because I want to see how VLC does it. I want to see how Ardour does it in a famous DAW, or how Juice does it, right? I mean, Juice is used by Traction, and sort of the audio backend for Traction is Juice. So the open source nature of Linux really is really easy there. Yeah.
Okay, nice. Yeah, so that's kind of reverse engineering other people's code to write your own. Okay, nice. And another question from the technical parts, because it's, I see it time and time again. It's even spoken about at CppCon that people, consider abandoning C++ completely in favor of languages that make it easier for you not to make the mistakes, or make it harder for you to make mistakes, especially related to data races and memory safety. So my question to you is, if you were starting, a greenfield project right now in audio, would you still choose C++ as its programming language?
That's a really, really good question. I think that this really depends. And so if it's just me, I would use C++. And But I don't know. I'm sometimes back and forth on this, but I would tend to use C++ because I think especially modern C++ almost allows you to write sort of the business logic in a way that it looks like Python or Lua, right? Yep. You do everything value based. You do a lot with lambdas. There's this great talk by Herb Sutter where he writes a garbage collector. And he doesn't tell you that he's writing a garbage collector, and at the end he's like, so what did we actually just write? And then it's like, wow, we actually just wrote a garbage collector in C++. And he has that garbage collector public, and I use that in all my personal projects. And so you really have like a garbage collected language that's so similar to something like Python or Java. Maybe Java is more closely related. And I'm a bit old school there because I like that, because I know that I can still sort of, I'm such an expert at C++ that I just know, like, I will not hit into these things like where I just don't understand why it's not working, right? So with Python, at one point, if I'm a large project, I just don't understand like why that doesn't work, and I can ask ChatGPT, but ChatGPT doesn't know it either, and so it's really just my laziness that I haven't learned another language that well, and My brother, who is a brilliant programmer as well, right? We both learned programming at the same time in life. He's constantly we're in a big disagreement about that. He's always saying like, you should really learn Python. He's always telling me like, you're nuts. Like writing everything in C++ is just stupid. And he has a big point there. Like I write scripts in C++, and it's like that's just silly, right? And I think he's right. But then I'm always in Python. I'm like, how do you do this? But I would totally restrict that to personal projects, because once you have more developers there, you really have to think like who you can hire for. Like if I've been on projects where the whole plugin UI has been written in HTML and JavaScript, and I think that's great, right? Because you can get the best, also just from a cost perspective, getting a good UI developer who's proficient in HTML and JavaScript is so much easier than getting one who knows how to write Juice UI, and so much cheaper. And so I think that's a great combination. I've used in academic settings when I had to collaborate with people, I used Lua. So I also know a lot about Lua, and that integrates really, really well with C++. So, and Lua is great because you can understand to program, like Lua comes with no big standard libraries, not with tons of types. Lua is so simple. You can learn Lua in an afternoon and you're an expert Lua developer. But it supports classes, it supports like all the things you like. And so like Lua is super, super simple, super easy to integrate. So I recommend that. And then I was responsible for the Android port of Juice. So I know a lot of Java. So I'm super old school again. And I had to learn Java from the low level up, right? Because basically Juice on the fly generates Java virtual machine instructions to do some of this glue code. And so I really had to learn like Java assembly first, and then learned like how class structures, and I really learned Java from the ground up. So I have this confidence in Java where I'm like, there's this great shared library, but I really understand what's going under the hood, exactly what's happening, to not like be stuck. And I always want to have that confidence. So I think if I would have to not choose C++, I think I'd go with like a Java C++ combination, something like that.
Okay. And I think it's worth mentioning also at this point, it has been proven scientifically that a developer is 3 times as productive in a language that they know very, very well. Right, so I know it's obvious that you're more productive in a language you know, but it's can be 3 times the difference. So
wow, yeah.
you probably would need to then spend again 10 years learning a new language.
Exactly. Yeah. So that's why I do everything in C++. But I do try to I almost have a different, a language within a language. I've written my own sort of library functions. And have this huge, library that I have that I can use from all my projects that I've accumulated. And there's sort of a low level version of that for DSP, and that's like very C++ as you know it, like all atomics. And then I have this high level thing, which is very much my own thing. It uses garbage collection. So, I don't use std vector because it's not, I really want that C++ to look like Python, right? So it's like I'm using high level objects. I'm heavily using inheritance. Everything is inheriting from a single root object. So very, very old school Java-ish type of development. And I think that's part of my generation. Newer people say, no, don't use inheritance like that. Use lambdas more. And I think they're right, to be honest. I think I'm just too old school. I think there is a new thought of development, and I just belong to the old guard. But it works for me, right? So,
okay. Yeah. And I'm just curious: are any parts of this library or these 2 libraries, open to the public on GitHub or somewhere?
I should really. No. Okay. I will. I have this project with Timur called Krill, where Timur also has like this stuff he constantly reuses, but it's like in no way, I couldn't, there's not even a single version because I fork it for every project, and there's no this is the best version of it.
Yep.
I would just say, at that project, I slightly changed that function and it's more fitting, so I'll use that. It's just a mess, right? And it's more in my head than it's really, there's no one. And so we have this project called Krill that Timur and I created, where we want to sort of move, some of that stuff into a more official manner. But Timur has just had a child, and I've been busy contracting, so I never really found time to contribute much, but I definitely will this year add more and more of my personal code into that.
Yeah, but I totally understand. And it's something for you to use, and where you don't have to think about backwards compatibility,
right,
etc. And then if you make it public, then first everyone starts using it. And then they start asking questions and then requesting features. Right, so it's like what we said, with writing something for your friend and creating a whole product. And with such a library, I imagine that it's even worse, because then you get into the situation with the Juice forum again.
Right, and so many things. It's really, when you're working on a project, that there's a huge limitation to this function that's really, really bad. Maybe it has memory leak, and you really have to think of manually freeing it. I don't have that, but let's just pretend I did.
Yep.
And for that project on a deadline, it might be better to just leave it that way. I think that's also something, again, of this over engineering, especially when you work for a financial company. You really have to I always think, refactoring is good, but always think of the end value for the customer. And refactoring does have an end value for the customer because you might be able to write more code faster, release features faster for the end user at one point. But I see so many people prematurely rewriting their code, restructuring the code, and especially beginners who think, they're at one point of the code and they've written half of it and they're like, whoa, I should have written it this way. And then they completely dump everything and rewrite it and they never finish. And the thing is really every time you write something, always think of the business case for your customer. Will a rewrite will it benefit your customer? And, it's almost always no. Okay, so this one function would be really hard to rewrite to make it release the memory or hold on to the memory. So you have to free it outside. So just do it. Write a big comment on it. Say, due to this and this, the free has to be outside, because your customer doesn't care if the free is outside or inside, right? Make sure that it's a big fat warning so that, you don't get any crashes in the future. But that's okay. Again, this dogmatic or this sort of beating yourself too hard, it has to be perfect. No, always think of what end value it has for the customer. And yeah.
Yeah, so I think for me it's this perfectionist approach is very dangerous because it then limits your output in a way that it's not beneficial for the end goal. So yeah, thanks. I'll keep this in mind. Okay, and then I have one last question that we touched on a little bit in this talk. That is technical, and this is a kind of a longer one. So you have such an extensive experience in working with all sorts of audio applications, right? And I feel that, whenever I read a book or a course on software architecture, I can't help but think that, okay, it's very nice, but this does not apply to audio. And as, for example, audio applications of today are not meant to run as microservices, right? In the business space, you have microservices everywhere, but in audio, it typically sits on one machine, and which sometimes may not have an operating system at all. And the audio software needs to communicate with the machine directly. And sometimes, you need to you cannot use tools that produce additional overhead. So yeah, people will say all the time that, C++ runtime polymorphism has this indirection and should be avoided in, very performant code. And yeah, some of this may be true, some of this may not be true. But what I found really lacking, so as there are very few resources on real-time audio programming, and your real-time 101 talk with Dave really helped immensely in this space, my question is, are there, any patterns that apply to audio applications, so high-level architectural patterns that you've noticed over the years, and how an architect should design an audio app or a plugin?
Ooh, that's a really good question. I mean, one part of the question is books. I don't know. I think we touched on this multiple times already, but I think you're so right that in this audio space, you cannot use some of the general wisdom that's out there. Even if we go to things like, don't use inheritance, even some of these newer sort of topics, or use std future, or use these kind of, they just don't apply to audio.
Yeah,
you
exactly.
can't, and that's also a problem, with some of these other languages that I find, using it for audio, like Swift, trying to use Swift for audio. They have these great concurrency patterns, and they say, oh, well, it doesn't really matter. We have this thread pool, and that stuff will run on any thread, and that's just unacceptable in audio,
yeah.
right? And so there's so much where audio is just so different. So, you have to be, and it's so dumb, because you almost have to be an expert to know which advice you're allowed to take and which you're not. So it's almost this this impossible conundrum. And that's why I think, platforms like yours are so valuable that focus on audio development, because it is something different, and it's really hard for a beginner to find their way into this realm. And now your question is which architecture do I often reuse? I think to be honest, it's a simple answer, because if at least for a plugin, it's a simple answer because the plugins all dictate an architecture for us, right? So they have this notion, especially if you're looking at AAX, but also I think AUV3, they have this notion of, okay, you have this business logic layer, also, or VST3 even more, I think. In VST3, they have this split between edit controller and then the processor. That's what they call it, right? So you have this, and it's a hard split, right? It's even so that the processor could run, no DAW does it, but theoretically the processor should be able to run in a completely different process than the editor. So you have this hard split between sort of the real-time part and the non-real-time part for audio plugin. That split has to be very evident in your code, and especially if you're writing a plugin, you have no choice other than to adhere to that split. And I think one of the downsides of Juice is that Juice kind of hides the split away. It's almost maybe if you're a more advanced audio developer is to try to develop against one of these plugin backends directly. I would recommend VST3 and AAX and AUV3. Definitely not VST2. VST2 is just a mess, right? That's like even worse than Juice. To give you, a good idea of sort of the architecture.
So let's say we're done with the technical questions. Now I have some more questions. If you are willing still to take them, related more to let's say self-organization.
Okay.
So one thing that I believe is especially important for writing C++, but then also high performance and real-time safe audio C++, is to be able to focus on a very high level while you're writing code or reviewing code. So how are you able to maintain that high level of focus?
Okay, that's a good question. One thing I would say is 90% or 95% of my work is not where you need that high level of focus, right? Or maybe that's maybe it's 90 or 80%, but it's something over 80%. Like 80% of the work is grunt work, let's be honest, right? 80% of the work is, I need the C API I need to use. I need to write some C++ wraparound. And I'm not saying you shouldn't concentrate there, but it's like, you don't have to have the same focus when doing these things. And Jules, again, my mentor Jules, he always called it the day after work. The day after meant you went on a night out drinking too much, and there's always day after works that you need to do. Like there's always some place where like, I'm just not in the mood. I'm just not in that space. There's always some part of your project that is just grunt work and mundane work, and you can go focus on that. And I feel like I would say even like 80% of the time, it also comes with experience, right? Like if I'm wrapping a C API in C++, I think a beginner would really have to think about the API and how it's good. And, for me, if this is not a public facing API, I listen to music then. I put on my headphones and listen to music and do that. And then you have these 10% where it's like, okay, DSP algorithm or public facing API, I don't know, something like that. Or a really complicated real-time problem, something like that. And so my answer is, it's just so seldom for me that I can just do it, because like, then for me, it's maybe like hour or two max that I have to be in the zone. And I can't do longer, really. And for me, paper or pencil, or now iPad and pencil is a great help. Like I cannot think about complex problems without. And if I look at what I dabbled after, it's like it's just lines or just weird things. Like it doesn't even make sense anymore. But I just somehow need to write it down. That's like a big help for me.
Okay, awesome. And I think this piece of information will be incredibly helpful to other people again, to stop beating themselves up that, I cannot, focus intensively for 8 hours straight.
Oh, no. Oh my God, no. No. But I would also say, like, it doesn't mean you can't code for 8 hours straight, right? It's something very, very different. I would really say like 80% of the coding is mundane coding. I don't know if you agree. I mean, maybe as a teacher, it's different because you're teaching the things that are hard, right? But, if you're writing, like so often you're just, I don't know what like so much of the work is just getting things to work somehow, and then the 20% is the actual algorithm, the actual thing.
Yeah, so I would agree that there is a ratio. So it's like you'll spend 20% of the time writing some pseudocode or how you want the thing to work, and then 80% trying to implement this and seeing that in this part it doesn't work, and maybe testing something, and then running some unit tests, and then why it does not compile, etc. So I agree with this approach and the value of pre-planning also.
I mean, and I would though. Go a bit, I would also add another thing that Jules said, which I would also say is still important, is one of the best things that Jules said is, and it's so simple again, and maybe you have to be there to really take this advice, because otherwise it's just words. But Jules always said, always be proud of your code. Always write code that you can be proud of, and that is such good advice, because sometimes I always try to listen to music that really goes back, that it's really good for background music while I work. And sometimes I'm like, but I'd really love to listen to this album. I really love to listen to this podcast while I work. And, you just don't write code that you're proud of when you do that. And it doesn't mean that you're in the zone, but just like write code where you say, this is a good piece of code. Like at least have the ambition to write that, and really, it doesn't mean you have to be in the zone all the time. Like, there's still mundane code that you can still write well, where you don't have to think too hard about. But so write code that you're proud of, but I don't think you need to be in the zone for that all the time.
Okay, awesome. And can I just ask, what music do you listen to while coding?
I love classical music usually. It goes so much into the background, but it also gives you like a flow, like, the tempo is so like it but this is so personal. Like, I know people who like, great coders. I think most great coders like listen to heavy metal, and I can see that working. Like, I love jazz, but I can't listen to jazz while coding, because jazz, you really have to concentrate on the music.
There's often not so much pattern to it, right?
Right.
But I heard also once that when someone gets annoyed with their program not working, then they turn on, the debugging session and some like really powerful heavy metal to give them boost. But I think it's so personal. It's so personal.
Yeah, it's so personal, yeah. Exactly.
I hope that no one will take this as an advice, to be a great coder, I need to listen to Glenn Gould while programming.
Right. No, that would be awful. Yeah.
And then while you're coding, what IDE and operating system are you using for development? And if if you are forced to use different ones, let's say which ones are your favorite?
Okay. Well, I was die-hard Linux Emacs for the longest of time. So, all of the Fielding DSP stuff I wrote in Emacs and Linux. And when I was at Rowley, that's when I switched to that's when I sort of half did Linux and half did Xcode. And nowadays it's like, I really don't need to do Emacs anymore. Half the time you're trying to get Emacs to do what you want to do. And it was great for learning, but but I think my favorite combination is still Linux and VS Code. I think VS Code is great. Like, I'm glad I'm not using Emacs anymore. Like, I'm glad for, especially debugging, I think debugging is something that's very good to be very visual. And so yep. Using Visual Studio Code for that is just perfect. I love Visual Studio Code. I think it's so much better than anything other than that's out there. And Linux, Linux is, I would really not recommend people to follow that advice, but I will say some positive things about it. Learning Linux was a huge time sink. I would say while I was PhDing and writing Fielding DSP, I would say half the time was fighting Linux, right? But I also learned so much, about this, what we said, like in learning real-time things, fixing kernel bugs. I had to understand how the kernel works, and I had to understand how the operating system works. And it was also part of my nature. I loved doing that. I loved understanding how Linux works. And another thing which is so good about Linux is, I don't know, many people, I don't know how many people will relate to that, but often you're using a third-party API, you're maybe using WebKit or whatever, and you're hitting this bug, and it's crashing inside the API, and you just don't know why. And of course, it's your bug, right? You forgot to, but you just don't know why. And with Linux, it's so great. You can get the source of every package. You can, that when you would want to step into a function, but you can't, you can do that on Linux. You can step indefinitely into all of the functions. And that's been a huge valuable tool.
Okay, thank you. I think maybe it's also a good advice to, if someone has a lot of time on their hands, to dive into this ecosystem as well.
Yeah, they have too much time.
So there's one thing that you mentioned that I wanted to ask you, because you mentioned the role that the mentors played in your life, and now that you're giving it back to the community as well. And I was just curious how, if someone wanted to be, your mentee, how does that happen?
I think via the mentorship program of ADC.
Okay.
So that's how I get my mentees. And then I think just naturally it happens, right? I mean, you have friends and yeah. Okay. But I mean, you only have so much time. There's something where you really want it to scale, because it doesn't scale, right? Like I have a small child, like I can't be mentoring all the time. So finding things like with Krill or with talks, and that's something I really want to focus more on this year, is finding ways that I can scale my mentorship, and something that's not necessarily one-to-one.
Okay. But I'll put the link to the ADC mentorship program in the episode notes if someone is interested. Okay, Fabian, thank you so much. I really appreciate. I have a ton of notes here. I think everything you said is a goldmine of information for people listening to it.
People say I talk too much, and I see it here's the proof in the pudding. My wife always said I talk too much, and I just can't stop.
I would disagree, because these are things that like too much. It always needs to be put in a context, and if there's not enough knowledge in the space, then there isn't talking too much on the subject. So last question is, if someone wanted to contact you, where do you recommend they go?
I guess LinkedIn, although I hate LinkedIn, but I don't know, like just for the general public, I guess LinkedIn. Do you have anything you recommend?
So I liked LinkedIn. I don't like Facebook so much, but LinkedIn is fine for me. I find it quite, transparent, so to say.
Okay.
But at the same time, I have this feeling that there are people who maybe should spend more time learning programming than doing this kind of LinkedIn programming. Right. That you spend more time on LinkedIn to advertise yourself. Right. Than actually working on your skills. Yeah. But that's something I simply find funny, and I'm not a pro LinkedIn user, so I can't tell.
Yeah.
Yeah. So, is there anything you would like to share at the end?
No, I've shared enough by far.
Okay, then thank you once again, and I wish you wholeheartedly all the best and much success in all your professional and private endeavors.
And also, if you need any help, or anything I can do for your platform, I'd love to do that. And it's such a great platform. So yeah, thank you for all your work you're doing.
Thank you so much. All right, everyone, that was Fabian Renn-Giles, a real-time audio C++ expert, and as you could hear, an amazing guy. Thank you, Fabian, for doing this interview, and I'm sure that everyone listening will be deeply inspired and motivated now to learn real-time audio C++ programming. If you, dear listener, would like to check out the people, places, and references mentioned in this podcast episode, then please head over to the episode notes at dwolfsound.com/talk021. Once again, it's dwolfsound.com/talk021. And if you like the episode, if you'd like to help the podcast, then please consider subscribing to the YouTube channel, giving a thumbs up to the video, or leaving a 5-star review on Apple Podcasts or Spotify. Feel free to suggest in the comments on YouTube or in the episode notes who you would like to see as the next podcast guest. And don't forget about your free resource at dwolfsound.com/checklist if you would like to become an audio software developer. Thank you for listening and see you in the next one. Take care.